Hey, good morning, guys. Today's video is going to be over magnetism. So we're going to be working on magnetism, still talking about force. Okay, so magnetism is also a type of force. Um, I have a magnet right here. So this magnet has a pull force. Okay, it has a force that attracts things that are magnetic, and then it repels the opposite of this magnet. Okay, so that's what we're going to be talking about today. We're going to do a little scientific experiment. Okay, so I want you guys to be paying attention and ready to answer these questions. Okay, all right, so let's get started. All right, so for this experiment, we're going to be working with a ruler, okay, to measure the distance. We're going to be working with a magnet. And then, of course, I have some items here that are magnetic. These items are definitely magnetic. As you can see, the magnet definitely attracts it, okay? So they're all the same in that sense, or in that matter, where the items are attracted to a magnet, okay? Okay. All right. So right now, what we're going to do is we're going to test the items to see which item gets attracted to at what distance, okay? Depending on the distance, that's how we're going to do an experiment. I want to see which item requires more force to be pulled. Okay, remember, if it requires the most force, do I have to be closer or do I have to be further away? Okay, if I need more force, do you think the magnet has to be closer or further away? Okay, go ahead and answer that. All right, we'll find out. Okay, at the end of the video, I'll definitely show you and we'll talk about which one is the one that it doesn't need more force to be closer or further away. All right, so again, these three items will be tested one at a time, and then we're going to use this ruler to measure the distance that the magnet needs to be close. Okay, so let's go ahead and start at 10, and then we're going to start with one of the items. Okay, so your hypothesis needs to be which item do you think is going to be the one that requires the most force? So you want it to be the closest. So whenever I move the magnet closer, okay, that might require more force. If it's further away, then it may not need as much force as if you were close. Okay. All right, so let's test it out. Let's start with the iron nail. Okay, so in your journals, you're going to set up a table. Go ahead and set up a table that has the iron nail, the washer, and the paper clip. So go ahead and set up a table, and remember, we're going to do it 3 times, 3 trials each, okay? So the table should look something like this. You're going to draw your washer, your iron nail, and then your paper clip, right? And then you're going to do your table, because we're going to do 3 different trials. So this is going to be trial number 1. This is going to be trial number 2. And then trial number 3. Okay, so this is the most simplest table that you can create with the items here and then the trials, depending on how many trials you're going to do. I'm only doing 3. Okay, I'm only doing 3 because in order to get accuracy and precision, I need to do at least 3 or more. That's called repeated trials, okay? Repeated trials. All right, so let's go ahead and start. So my first time, I'm putting it at 10, and it doesn't attract the iron nail. So let's move it in closer to 9, 8, 7, 6, 5. All right, notice that the nail was attracted to the magnet, okay, at 5. So in my note or in my table, I'm going to put for the iron nail, I'm going to put that it was attracted at 5 centimeters. So I need it to be 5 centimeters away to attract it. Now remember, we are going to do it 3 times. So I need two more times. Okay? 9, 8, 7, 6. All right, and notice that the magnet was attracted the nail at 6 centimeters now. Okay? So now I have 5 centimeters and 6. Let's do it one more time for accuracy, starting at 10, 9, 8, 7, 6, and notice that it was attracted at 6 again. So, looking at our data so far, the nail needs to be 6 centimeters away so that it can attract the it can be attracted to the magnet. Okay, let's move on to the next one. We're gonna go ahead and do the washer, the steel washer today. Okay, all right. So let's see at what distance does the washer need to be. Okay, go ahead and pause the video. What do you think the distance would be? What is your prediction? Remember, you have to predict. What do you think? You don't have to necessarily be correct, but you do have to have an idea. Okay, based on what is the difference between the two. So what do you notice that's the difference between the two? All right, go ahead and pause the video and then answer that question. All right, yes, definitely. I think mass would be the difference, right? They are both attracted to a magnet. Yes, they are a different shape, but they're both, the main thing is that they're attracted to the magnet. They're both going to start at the same time, so it doesn't matter if one is longer or the other. But the mass, notice that one is heavier than the other. This one has more mass, okay? So it might require a little bit more force. Let's test it out. 10, 9, 8, 7, 6, 5, 4, and it traveled at 4. Notice that at 4, the washer was like, ooh, I want to get there. Okay, so I'm going to put 4 centimeters. And I'm going to do a little bit faster so that we can get there. We can get through it with time. Okay, 9, 8, 7, 6, 5, 4, and I was about to move to 3, but before I moved to 3, it was at 4. Okay, and let's do it one more time for precision. 10, 9, 8, 7, 6, 5, 4, and once more at 4. Okay, so notice that my table now says 4 centimeters all the way because that's what happened for the iron nail, 5, 6, 6. Now we need the paper clip. So which one required the most force? The washer or the nail? Which one required the most force? That's the question of the day, right? Which one is the closest one, the one that requires the most force, or the one that's further away? Okay, we'll talk about that at the end. So let's see. We're going to move on to the paper clip. Okay, the paper clip at 10 should not be attracted because that's not enough energy. There's not enough force to pull it. So let's test it out. Okay, before I do, what do you think? At what number do you think this paper clip will be attracted to the magnet? At what distance do you think it will be attracted to the magnet? All right, let's test it out. 10, 9, 8, 7. At 7, notice that the distance is extremely long, and that is 7 centimeters. So I'm going to write that into my journal. Okay? And I'm going to test it again. 10, 9, 8, 7, and once more at 7 centimeters. Okay? And let's do it one more time for precision and accuracy. 10, 9, 8, 7, and there you go at 7 again. All right. So what we notice is that let's go ahead and review our data, okay? So out of the three, the paperclip, the iron nail, and the washer, the one that was the furthest from the magnet and got attracted was the paperclip. Okay, now which one was the closest to the magnet before it got attracted? Exactly, the washer. Okay, the washer was the one that got the closest. It had to be at 4 centimeters in order for it to be attracted to the magnet. Okay, all right. Now, let's look at why. Let's look at why. So, out of the three, we said that the paperclip didn't need it to be so close. So if I was a little bit farther away, it managed to attract the paperclip. Okay, so let's look at it in this way. Okay, a magnet has a magnetic force. Okay, kind of like the Earth. The Earth also does have that too. Now, this force, this magnetic field right here, is super strong as it's close to the magnet. Now, as it's getting further away, it becomes weaker and weaker and weaker and weaker and weaker and weaker. So it continues to get weaker as it goes further away. Now, what does that mean? That means that if it's weaker, you're not able to carry as much things. So if something is stronger right here, like think about a person that does professional weightlifting, the ones that lift things. Okay, if they're super strong, they can carry a lot of things, right? But if they're not super strong, they're weak, then they can't carry a lot of things. Okay, same thing for here. The further you are out away from the magnet, the weaker the magnet is. The closer you are to the magnet, the stronger it is. So in order for me to carry this paperclip, which really has not a lot of mass, it's much easier to pick it up if it's further away. Notice that I don't even have to be super close. Oh, because the washer. Okay, it just clearly picks it up. And for the washer, notice that it has to be closer. I have to get super close to the magnetic field for it to work. All right. All right, guys. So basically that was it for magnetism. Okay. I hope you liked this video. And this is really actually talking about force. Okay. We're investigating the forces on magnets. And not only that, but you're also doing a scientific method. Okay. We did the steps. We had a question. Okay. We did our hypothesis. We had our experiment. Then we analyzed our data. And then finally, we came up with a conclusion. Okay. So I want you guys to go ahead and set that up with my video. What did you notice? What was my question? What was your hypothesis about my experiment? Okay. How did I set up my experiment? And then what data did I come up with? And then finally, how did you conclude with my data? What could you conclude? All right, guys. Well, thank you so much for watching. I'll see you next time. Bye-bye.